So just so you know how Sketchfab works is, it's an interactive viewer, and this is what I recommend that you guys do. We're going to be putting our stuff up on Behance, and you can embed these viewers in there, and this is really advantage for somebody when you're showing your work, that they can come in and kind of see under the hood, so to speak. They can see all your textures and everything if you set it up correctly. So this is a pretty nice piece. Okay, so I'm just using my left mouse button, can tumble around. You can also hold the Alt down in your left mouse button, and you can move the lighting around to see how lighting is going to skate across the surface. So we can move the light around to see this side, or I can come around the back. So I'm Alt left mouse button, to move the lighting around. All right, now center mouse button moves. And now if you'll look down in the bottom right hand corner, there's some icons in here, and there's a little stack icon with 3 little pieces of paper stacked. This is called a model inspector. This is going to allow us to go in here and inspect the different parts of this model. So when I click on that, you've got a set of menus in here. Now right off the bat, I'm going to encourage you guys to work with PBR, physical base rendering. And what that means is when you look in here, I should see a roughness map and a normal map. Okay, if I see a roughness map and a normal map, then this is PBR. If I don't see a roughness map and a normal map, then it's not PBR. Okay, I would only look at ones that are PBR. Okay, the first thing I do, so when I have a student that's doing some of this work for me and they turn it into me, the first thing I do is I come over here and I click on matte cap, and this just shows me a gray shader on this. And then when I click matte cap with surface, this is going to show the normal map put on it. And you'll see this gets so much more detail when I go from the matte cap. This is with a normal map. And then with the normal map, it's putting all this extra detail in here. That's what the normal map's doing. Now, I'll also go down here and look at the wireframe. This gives me just a white with a black wireframe on it, and this tells me all kinds of things too. This is a pretty clean model. It does have a few issues, but overall it's a pretty clean model. For example, this right here, you see this where this is cut into? There's no reason for this to cut in two, but it doubles the amount of polygons that are in this piece. So this piece, and this piece, to me, now it's one thing if the wood was like broken or something, but this is straight across. There's no reason that this is cut in half but it doubles the amount of geometry on each one of these boards. So I would fix that. Same over here. But overall, this is a pretty nice model. Okay, no problem with this. Okay, we can also do a UV checker. Okay, this puts a checker pattern on it, and I'm going to show you how to look at this. Now, what you're wanting to see is that these are squares and they're not stretched. So if they're stretched in any way, then that's an issue. But then the other thing we want to look at is pixel density. That's the density of what the pixels are going to show up. So as in right here, can you see how this number is smaller than that number? That means we're going to see more detail here than we are there. So the pixel density, which you can think of as pixel density, it's only pixel density once you convert it into a bitmap. So in three-dimensional space, it's referred to as a pixel density. And you can see the bigger these areas, like the numbers, you can just look at the numbers, the easiest thing for me to look at. And the bigger the number, the less detail. So this wall is going to have it has fewer amount of pixels in its bitmap than this does. Same thing in here. This is going to have more pixels on it than this in here. So you'll see a shift in the sharpness, in which that the smaller the structure is, the sharper the detail will be, and the bigger, the more blurry the detail will be. So that's kind of how you can see these on this window right here is really highly detailed. Now, the thing to me that's a little funny about that is this window is going to be translucent. We're going to be looking through it, which is why it's translucent right now, which means we see less of what's on it. So to me, it's kind of odd that this is more detailed of what we won't see, which is kind of odd to me. So I wouldn't do it that way. Okay, so that's kind of what this helps us kind of evaluate, is how to make sure there's no stretching and to make sure that there's consistency in texel density. Now, there are times where we can vary our texel density. For example, on a character, we might want more texel density on the face of a character than we would, say, on the bottom of the foot of a character. But most places, one of the things they're going to be checking you is your ability for you to be consistent with your texel density. Okay. Now, another thing that we can do, I'm going to go back to my wireframe, is right up here, this says 3D in your viewport, and then it says 3D, 2D in your viewport. And what this does is it splits your viewport where I can see the unwrap of the bitmap over here for this piece. Okay, so I'm seeing it's 3D and 2D, and this can be zoomed in and moved over. Okay, and I can look at just the 2D if I want to. But this is a good valuation. Now, do you notice how when I put my mouse over here, this is changing from yellow, and then it's yellow here, and then it's yellow here? That's because when the person did this, they're using 3 different bitmaps. They didn't unwrap it all on one bitmap. Every one of these yellows is a different one. So when I click on this, you'll see that my bitmap over here changes because this is the bitmap that's used for this. If I click here, it's going to show that bitmap. If I click up here, it's going to show that bitmap. So really, let's see, and right up here in the top right-hand corner, yeah. So they've got 4 different bitmaps in here. 4 different bitmaps. They've also got an interior one. So this is a model where they've done the interior too. So we can actually go in and look at that. So they've got a bitmap for that. Here's the bitmap for the glass. So they got the glass on its own bitmap. I don't see a reason that you would do that. Maybe it's a really small bitmap, but anyway, so this has 1, 2, 3, 4, 5, 6 bitmaps for this, which is, seems to me would be a little bit of waste. I could have probably done it and it'd look about the same with maybe 2 maps, 1 map, 2 maps. Okay, so that's what's going on there. All right, so let's go back to 3D. Now let's look at some of these maps. All right, so I'm going to go to the specular. Okay, now the specular should be a mid-tone, which is what it is. Okay, what this is controls the highlight that's going to be on anything that's not metallic. And so it should just be left at its default setting, which is about 50%. So that's correct. Now, I've got an emissive here, and I don't know why they've got an emissive because I don't see anything that needs an emissive. So I'm not sure why they're causing us to process an emissive map. Emissive map is glow, like a candle light, and they don't have that. Now here's their opacity, okay, and this is why I was saying we can see through the window. So in an opacity map, everything is reading from white and black, okay. Think of it this way: white is on, black is off, and gray is a transition between them, okay. So where this is becoming darker, where it's white, it's opaque, okay. So white's 100% opaque. Black would be 100% transparent, and then gray is translucent. Okay, so we see part of the way through it. Look how they've got a nice roughness to this. Okay, this means that this glass is going to come off as kind of dirty. Wherever it's darker, we can see more through it, and where it's a lighter gray, we see less through it. And so that's nice that on the surface, they didn't just make it a solid gray. They're making it varied so that the amount that I can see through it varies. Okay, that's on an opacity map. Not everybody will have opacity maps because you may not have something that's translucent. Okay, but in this case with the windows, that's kind of nice because we can see in it because this person textured inside too. All right, we go to an AO map. Now, AO stands for ambient occlusion, and what that means is anytime you have 2 surfaces that go together, okay, the light's going to make it dark where they go together. Okay, that's an occlusion. Okay, so what this does is this is a lighting that shows how when that, because light emanates in an orb, so it's round, so anytime you get two things that are creased together, it's going to get darker in there. Now, personally, I think this is a little heavy. It's almost what I would call a dirt map. I think it's, it goes up too far. I would have controlled this so it was a little bit tighter, but this is creating the shadowing that's inside. Of course, you can see inside of this window. We can see inside of there. And that's an ambient occlusion map. Okay, here's your normal map. And a normal map is a type of a bump map. So a normal bump map is black and white, whereas white pushes out or up, and gray is no movement, and black is back or in. But we're at a state now where we use this advanced bump map. It's called a normal map. And so this is the normal map. Now, this is what is being applied onto this mat cap. So when I go to mat cap and I'm just seeing the geometry, as a matter of fact, I can go up here if I want to and I can turn the wireframe on it. Okay, and then once we get mat cap surface, then we're applying this map, and this is what it looks like, and it's giving us the illusion of three-dimensional depth. Okay, as a matter of fact, we can see here. Let me turn the wireframe off. Can you see, and I don't know how much you've been seeing this video, that this right here is much sharper detailed than this in here? This gets really fuzzy in here. Okay, that gets back to your UVs. See how small this number is, 14, and how big this is? That means there's more detail here, less detail there. And that's what we're seeing here, is we can see all this nice detail of this wood, which is nice, and then it's very fuzzy in here, and that's because their textile density varies. And I can tell you really why they're struggling with that is because they're doing multiple bit maps, and so it's harder when you have multiple maps to make sure the scaling is the same. But that's what's causing that. Okay, so that's your normal map. Okay, then you have a roughness map. Okay, the roughness map is one of the heroes. Okay, one of the hero maps. Everybody should have a roughness map. Roughness map determines how glossy or rough the surface is. So white is off and black is on, and since it's in a roughness slot, that means white is rough or dull or matte. Okay. Black, if it was black, though we don't have any black in here, a little bit maybe right in, darker right in on this handle, is reflective. Okay, pure black would be like a mirror. So gray is a mid-tone reflection. So where this is lighter, it's going to be very matte and dull, and where it's darker, it's going to be shinier, and then the other gray is fall off in between. So this varies the surface so that it's not the same sheen across the surface, that some areas are a little bit more than the others, which is what happens especially over time when things age, because basically on a house like this, you have a piece of wood, then it's usually painted with a primer which kind of seals the wood, and then they paint an enamel on the outside of it. Okay, over time, weather with rain pounding on it, and also UV rays from the light fading the paint, then the surface varies, where some of it is a little bit more shiny and some are less shiny, and so that's what's controlling this. Okay, then you have a metalness, okay, shader. So basically your material has two algorithms in it. Okay, one of them is an algorithm for normal non-metallic surfaces. Okay, they're broken down into what's called an insulator and a conductor. This is from science class. A conductor is anything that conducts electricity, which is metals. And an insulator is anything that doesn't conduct electricity. Okay, so in a metalness, anything that's black is a non-metal shader in it. Anything that's white is a metal shader. Okay, Normally, these would only be black and white because something is either metal or it's not metal. Okay, and I see people all the time putting a lot of grays and stuff in it. And I'm not saying you can't do that because you may have a specific look that's a non-believable look. But if you're based on physics, something is either metal or it's not metal. Now, the exception, and we can get in here on this little hinge in here, and you'll see there's some grays in here. And what happens here is metal, through weathering, will start to oxidize. So we have oxygen in our atmosphere is a corrosive, and we have oxygen in water. So basically, we can think of water as like an acid, okay? And the oxygen in the atmosphere is like an acid, and it attacks metal. So what's happening here is you're getting oxidation built up on this metal, okay? Well, oxidation is like you can almost think of it as like a fungus growing on it. And so that oxidation is blocking the metal. So it's a metal surface, but you've got this organism, kind of the way you can think of it, growing on it, and it's kind of obliterating the metal. So it's like a coating on top of the metal. So in those particular cases, we can get in with some gray in there where we're still seeing a little bit of the metallic attributes through that, but it's starting to grow something on top of it. Other than that, it will normally always just be black or white. So since it's in a metalness slot, white is off and black is on, okay? And so we put metalness in here. If you don't have metal on yours, then you won't have a metalness, okay? All right, so white is on, black is off. So anywhere that's white, metal. Anything that's not white, black, is non-metal. Now, they're indicating here that this has some kind of a metallic surface. So this is like a tin roof is what I'm getting from this. So it's not a wooden roof, it's like a tin roof because it's metal. Okay, base color. This is where we're just doing flat color. No shadow or anything. It's just flat colors. I say flat color, or it could have pattern in it too, but I mean it's no shading. Now, we can inspect here too. So when we're looking at a base color, if we go over here, let's go and click this surface, then you'll see here is that color. Now they put this pattern over it so people can't, steal people's texture maps. I hate it because I'd like to be able to evaluate somebody's texture map more, but it's something that they added at one time in here. Okay, so that's your base color. Okay, then you'll see in here it's got final render and a no post-processing render. So we click here, and this is stacking all of these maps on top, and this is what it looks like. Okay, and we can move the light around to see it. See, we're seeing that sheen up there on that metal tin roof. And then you'll have one that says final render, and you'll see there's a shift in here. Okay, and so the inside of Sketchfab, there's some post-processing that we can do. Like it's got a vignette, darkness in the corner. That's what happens when we shoot with a camera. The light is an orb, so it gets darker in the corner. So there's kind of effects we can do. We can throw a shadow underneath it on the ground plane below it. So that's kind of your procedures of how you can go in here and you can see people's stuff.